There is a famous graph that shows ice cream sales and shark attacks. But does the first cause the latter? In statistics, we must differ between correlation and causation. Correlation means two things move together at the same time. Causation means one thing causes a change in the other. But there is more to it. Correlations can be positive, negative, or zero. Think of ice cream sales and shark attacks, ice cream and raincoat sales, and ice cream and the number of pirates worldwide. They can be weak, strong, or even perfect, like hours playing video games and slices of pizza eaten, time spent studying versus test scores, the number of left and right socks produced. Causations exist if one thing affects others, often multiple things. The effect can be strong or weak, and between effects we often see correlations. But there is one problem. Our brains love simple stories, such as X causes Y. This is why when we see a strong correlation, say kids' shoe size and reading ability, we may think of causation. But 3 solutions help us avoid these errors. As kids grow, they need larger shoes and get better at reading. If a third factor drives correlating results, we call it confounding. Then there is reversed causality. We may think that ice cream makes people happy, but maybe happy people just have more reasons to buy ice cream. It's not that clear. Spurious correlation exists when patterns appear by chance. For example, as the number of pirates decreased, we recorded increasingly hotter days, but there's no plausible common cause. There are 3 questions to test a causal claim. Did A happen before B? What could cause both? Is there a plausible path from A to B? Suppose someone claims that students who sleep more get better grades. Does longer sleep come before better grades? Do organized students maybe do both, sleep more and study more? Sleep may boost attention and memory, but can it explain better grades? To look for a real causal link, serious social scientists typically turn to 3 methods. In randomized controlled trials, people are randomly put into 2 different situations, say school classes with 15 students and classes with 25. Scientists then look at what happens and may find that one group learns faster than the other. Ideally, that experiment then gets replicated. RCTs are considered the gold standard of research. Natural experiments are real-world events that create as-if random groups. The Mariel boat lift is such an example. In 1980, 125,000 Cuban refugees arrived in Miami almost overnight. With all these new workers, local employees feared for their jobs. But economists later compared the situation in Miami to similar cities and found wages were hardly affected. Longitudinal studies track the same people over many years to check time order. The Grant study, for example, tracked 268 Harvard-educated men since 1938. It found that alcoholism was the main cause of a divorce and that men who earned more typically had warm childhood relationships with their mothers. Those who earned less didn't. To help us find a causal link, it's useful to compare apples with apples, such as grouping people by age, income, or lifestyle when we study them. Now it's your turn. Imagine you see this headline: Kids with more books at home do better in school. First, ask yourself the 3 questions to test the causal claim, and then design a test to find out. Share your findings in the comments below. If you found this helpful, check out our other videos. Join us on YouTube or on patreon.com/sprouts. For more information, classroom exercises, or videos without background music, visit sproutschools.com.